Hello, this is Mr. B. I want to go over some information with you regarding percents. And this is some basic information about what percents look like, the type of problems that we see in 6th and 7th grade percent problems. Specifically, we're looking at these three words that make up all percent problems. That is the base, the percent number, and then the amount. So we're going to be familiar with these three words: base, percent, amount. They all can be found in these problems and these types of problems. And I kind of want us to wrap our heads around the types of problems that we see, and also can we identify what number is the base number, what number is the amount number, and the percent number, and just some of the intricacies of these words. Starting with the base right here. So when we see the base is 100%. It is the whole, it is the total amount. So when we're reading a problem, we want to make sure, can we find the total amount? What number is it that's the whole or the total? It also goes by other names and other things. So we can see here, if we're faced with a fraction, it is the denominator of the fraction. That makes sense because denominators of fractions are the whole or the total. It's also, if we're talking about prices and a price that would change, for example, if we go to the store and we're looking at a coat or something and it's on sale for 25% off, the original amount of the coat, that is the base number, the original starting amount. It's the starting amount if something changes, if we're looking at how a number or maybe your grade in a class changed from one grade to another, we can find a percent of that. The starting amount, or the original, is the base number right here. We also have a percent. Percent, of course, we understand is a ratio of a number to 100, comparison to 100. So it can be above 100%, it can be less than 1%, it can be a fraction or a decimal number. So that's pretty easy to find a percent number in a problem. And then the amount right here, the amount is the part. It's the part we're looking at. If you're thinking about a fraction, like 3 out of 4 kids in a classroom are wearing tennis shoes. Well, the 3 is the part and the 4 is the base. So it is the part that is related to the percent number. So a little more on that. Let's focus on this base number right here a little bit longer. And we can see, well, we'll see all three of these numbers in what's called the percent proportion. There's two ways we can solve percent problems. There's probably more than that, of course, but two general ways. One is through a proportion and one is through an equation. Okay, we're going to focus a little more attention this year on the proportion, but the equation is very similar to this, and it works pretty much the same way. The proportion is set up like this. Of course, we know that a proportion is two equal ratios. They are two equal ratios. The ratio of one side is the amount over the base. That's a fraction. 3 out of 4 are wearing tennis shoes. So 3 is the amount, 4 is the total or the base. That we can equate that to a fraction. But there's an amount, there's a base, and then the percent number, of course, is related to 100. So that's written as one ratio for the percent number over 100. And if we set them up equal to each other like this correctly, then we can simply solve it the way we understand how to solve proportions. The equation is very simple, and it's about the same thing. It is the base number, base, times the percent number, or oftentimes we'll start with the percent. Percent times the base times base, and that will percent times base equal the amount. And you can see that in our way that in 7th grade, how we solve a proportion, how we can cross multiply. What do we multiply together? The base times the percent, right? And then 100 times the amount right there. That's the 100 is not included in this because when we write the equation, we will write the percent as a decimal number. So we'll go ahead, instead of writing it as a whole number over 100 or the percent number that we see over 100, we'll change that. So we don't have to worry about the 100. We're just multiplying the base times the percent here. So these two are very closely related. You can use either way to solve percent problems. We're going to focus a little more this year, at least, on the using a proportion. Okay, so let's take a look at some of the problems that we'll see in this and talk about the base a little bit more. So here's a problem. It's a conundrum. That means it's kind of a puzzle. John ate 1/2 of a pizza. That's 50%, right? Tesh ate 1/4 of a pizza. That's 25%. It says here, Tesh ate more pizza than John did. How could that possibly be? How could it be that Tesh ate more pizza when we know for a fact that 25% is much less than 50% of a pizza, yet still she ate more pizza? Here's what we can see right here. Tesh's pizza was larger. Yeah, that's the fact right there, so that we can see that 1/4 of this large pizza is much more than 1/2 of this tiny pizza right here. I'll take this pizza right here, thank you very much, but we can see this is a problem involving different bases. The base or the total is different in both of these, so we're ending up with different answers for this. So when we are comparing things or comparing two people or looking at percentages, we also kind of want to make sure we are studying or we're looking at the same base number. Okay, this is a problem looking at page 150 in your 7th grade book. You can take a look at that with us, or you can just kind of continue watching this. In science class here, students compared their vertical reach and height to see if they are proportional. So I guess what they did, this is kind of interesting right here, is all of the kids in the science class stood up, they measured their height, and then they reached up, they measured their vertical reach, just like you see Maria doing right here. And then they looked at the ratio of height to vertical reach, and they questioned, are they the same ratio? Are they equal ratios across the board? That would be easy to do if we could just change all of their ratios into percents, and then we'll just look at each of their percents and see if they're the same number or very similar numbers. In this case right here, in this question, we're looking only at Maria. We're not looking at any other students, and we're asking the question, what percent of her total vertical reach is her height? So we want to set up a problem. We want to set up this ratio to answer a percent question. Remember, we're looking for three numbers: the base, the amount, and the percent. So the answer, or the way we can identify those, is found right here in the question. First of all, it says what percent. That tells us we don't know the percent. It's the what of the problem. So we're not going to know percent. We're going to just represent that by the P right here. Secondly, we see it's a percent of her vertical reach, percent of her total vertical reach. In all of our problems, we'll take a percent of the base. That tells us where the base is right here. It's always percent of a total, percent of a whole, percent of the base. So whenever we see that word of or percent of, that tells us the base is coming up. Here it is right here. It's the total vertical reach. So if we can see right here, 75 inches, that's going to be our base number right there. And then her height is going to be her amount. That kind of makes sense if we set up our proportion like this, 60 over 75. That's a fraction, right? It's her height compared to the total vertical reach. And the rest of our proportion would look like this. Now we've set up our proportion. We don't know what the percent is, but we can use our method of solving a proportion to solve for the percent number. And that would be our answer right there for that problem. So finding the base, by looking at that question right there, we can see percent of whatever comes next. That's our base right there. Let's take a look at amount and percent. I've got a few notes here about those. Specifically, that the amount and the percent are related to each other. They must represent the same thing. Here's what I mean by that. Let's take a look at this example. This example looks at a coat and it's on sale. All right, so the price of the coat, original price, is $15. And we can see that the discount is 25% off. All right, so you get 25% off this coat. The question, well, it doesn't really ask a question in here. It just says, what can we find out? Can we find out how much you're going to save? Can we find out what the sale price is? You know, how much you're going to have to pay for the coat now. So we've represented the coat right here with a circle graph right here. The entire circle, the whole thing, is the base. It's the total, the whole thing. The original price is our base amount right here, and we can see that 25% is 1/4 of that. So we've got this little section right here, 25%. We want to take that 25% out of the original price. In other words, we're going to subtract it out of the original price, and what is left over down here is going to be the sale price. That's how much you have to pay for the coat. Let's just go ahead and see how, move that up here. How can we set up our proportion? So the amount, the base, percent, we need to identify those things. The percent's pretty easy to find because it has a percent symbol on it right here. So let's go ahead and we can start by putting that 25 over 100. We have our amount and our base to find. Of course, we've already said the base is going to be the original price, so we know that $15 goes down here, or the 15 goes down here. We don't know the amount. What does the amount represent, though? Is it the sale price? Is it the discount? The amount's going to be a dollar amount, right? But what does it represent? Which one of these two? Well, we notice in our note right here that the amount and the percent represent the same thing. So if we're using 25%, which is our discount, then the amount that we find is going to be our discount amount. That's how much we get to save. So we can use our method of cross multiply, we can divide, or we can use any other method to find our answer. And when we solve this, we see that the amount equals 3.75, so $3.75, and that is going to be the amount of the discount. Because the percent and the amount represent the same thing. They both represent the discount. Now the question is, what would you do now to find out what the sale price is? Well, if your original price is $15 and you save $3.75, you probably understand that you need to subtract those to find the sale price right here. All right, let me erase these right here. And now let's change this around a little bit. Let's say the 15 was not the original price. The 15 was the discount amount. So now our problem looks a little bit different. Here's a coat that's on sale. We don't know how much the original price was, but we do know we saved 25%, which is $15. So we saved $15. So the question could be, how much is the original price? So let's go ahead and set up our problem now. So the amount is the amount of the discount. They match. They both represent the same thing. So that is our amount right here, 15. Our base, we don't know what that is. That's our original amount. We are not sure what that is. That's what the question is. What is the base? And then 25 over 100. Of course, once we have this set up, now we can solve our proportion simply the way we normally solve it. And when we do that, we see that our answer is $60. So that is our base. The original price is $60. It's a $60 coat. We got 1/4 of it off, and we saved $15. Next problem. Let's kind of switch things around here. What happens if the $15 is the sale price? Okay, so now we have a coat that we don't know the original price, but we saved 25%, and the sale price is now $15. That means you have to pay $15 for the coat. So let's start setting things up here. If the amount, the base, well, the base, we don't know the base, right? What's the original price? We don't know what that is. We do know that 25% is the percent of the discount right here. So if I'm starting to set these up, I'm starting to see that there's a problem here. If 25% is the discount, what's the amount? Is the amount 15? Because here the amount, $15, is sale price, but over here the percent is the discount. We have an amount that's one thing, and we have a discount that's a different thing. So we have a problem here. They don't represent the same thing. We need to do a little bit of math here, or change things around here, so that we can understand the problem with the same percent and amount together. We need the percent that belongs here. What's that? So we can just kind of logically think about this. If I know that the entire original amount is 100% and I save 25%, what's the percent that I pay here? Of course, yes it is. It's 75%. So we know now what the percent of the sale price is. So here's another way of saying it. We don't know what the original price is, but you're going to pay 75% of that to get to pay $15. So now we're going to erase this 25 here. That doesn't belong there. That is not our percent in this problem. Our percent is 75% because that will match the 15 amount. We paid for a coat for 15 bucks and we paid 75% of it. Now let's figure out how much the base is. Okay, and we find out that the base is $20. $20 is the base. So after you use your process for solving a proportion, you can find out either of those three numbers. You just have to make sure the amount and the percent things both represent, either they both represent discount or they both represent the sale price, or so on. So that's a little bit about how a percent problem works and how to identify the base and the amount, the percent, and get those set up and solved correctly. All right, thank you. Bye, guys.